Hello, welcome back to Math with Patrick and Quill. Today is July 18th, and we're solving problem number 199 from the Daily Epsilon calendar. And we need to figure out why 18 is the smallest positive integer that is twice the sum of its digits. Well, let's try to see what happens when we pick even smaller positive integers. So the smallest positive integer is 1. Integers are just like whole numbers. Integers could be negative, so like -2 is an integer, 0 is also an integer. But if it's saying positive integer and the smallest positive integer, we got to start with 1. And we want to see if this number is twice the sum of its digits. Well, fortunately, all the numbers 1 through 9 are pretty easy to check and then discard because, for example, like the number 9, its digits are just 9, and surely 9 is not twice itself. So we need to now look at two-digit numbers and see if we can figure out any pattern here with these ones. So 10, potentially, could be the smallest positive integer, but we need to see if it's twice the sum of its digits. Well, adding 0 and 1, we get 1, and if we double that, we get 2, and that's not 10. And so let's see what happens if we just kind of keep going through this pattern where we add the digits together, we double it, okay, that's 4. We add the digits together, we double it, that's 6. So we can kind of see how the sum of the digits is kind of creeping up on the value of the number. This is increasing by +2, whereas this is increasing by +1. So surely it'll catch up, I think. Well, I mean, it does because we both know the answer is 18. So I could just kind of continue this pattern without needing to do the computation, really. I know it's going to be 13, then 8, 14, 10, 15, 12. And so now it really does look like it's catching up. 16, 14, 17, 16, and then finally 18, 18. So here's the first number that satisfies the condition for today. And all the other ones don't. I just wanted to see how we could maybe solve this with algebra. So assuming that we already checked these one-digit numbers and we know that this is not going to work, once we pick a two-digit number, let's just call it like D1, D2. And what we were doing here was summing the digits together. So this number right here would be like D1 plus D2. And then finally we doubled it because it's like twice the sum of our digits. And then so we got 2 times D1 plus D2. And then over here, we can also kind of extract the value out of our digits by multiplying the first digit by 10 and then adding it to the second digit, right? Because if we have like any two-digit number, say like 32, this is going to be the same thing as 3 times 10 and then plus 2. This is kind of like the basis of base 10 arithmetic. So we are essentially trying to figure out when this doubling of the digits is the same thing as 10 D1 plus D2. If we investigate this a little further, we could try like isolating one of these variables, kind of like as if we would get like a y equals mx plus b scenario, like isolate one of the variables and make it like a function of the other. So 2d1 plus 2d2 equals the right-hand side as is. I think it would maybe be easiest to isolate this d2 because I could just subtract a d2 from both sides. I would get d2 here. And then how about I subtract the two d1s from both sides like that. And so these terms cancel, these terms cancel. This is 1 d2. And over here we have 8 d1. And so now we have a pretty direct relationship between the first digit of our number and the second digit of our number. Assuming that we are working with two-digit numbers here, it means that the second digit needs to be 8 times the first one. So we could try a few two-digit numbers. We could make D1 0, 1, or 2. And then using this rule, D2 needs to be 8 times D1. So we would get a 0, 8, and then 16. And so 16 isn't a valid digit. That's a 2-digit number. And then if we try the number 0, that is not a positive integer. Where I guess it's actually kind of funny that this equation right here actually gives us technically another valid solution. Because if we did get rid of the word positive here, find the smallest integer that is twice the sum of its digits, we could take 0. The sum of its digits is 0, and when you do twice the sum of the digits, we also get 0. So that integer is equal to twice the sum of its digits. So that word positive is actually really important in the problem. I didn't realize until kind of working through all of this that maybe you would get another solution in 0. Anyhow, the real answer today is 18, and I'm all done for today. So thanks for coming along, of course, and I'll see you tomorrow. Bye.